substances which release H positive protons in aqueous solution. This means acids are substances which, when dissolved in water, give off H positive ions. Uh, if you look at hydrogen atom, it has one proton and one electron. And if you remove this electron from here, you will get simply a proton. So proton and H positive ions are equivalent. So no harm if we write H positive ions as protons. According to Bronsted and Lowry, acids are proton donor, they give off proton, and bases are just opposite to it, they are proton acceptor. You can take the example of hydrochloric acid. When hydrochloric acid is dissolved in water, it deassociates or ionizes into H positive aqueous and Cl negative aqueous ion. So you will find H positive ion in HCl. Strong acids ionize or deassociate completely in water. For example, if you take sulfuric acid, it breaks into 2H positive and SO4 2 negative. It's a strong acid because if you have 1000 molecules of H2SO4, they all ionize or deassociate into 2H positive and SO4 2 negative. So strong acid ionize completely. On the other hand, weak acids deassociate or ionize partially in water. You can take the example of ethanoic acid. Ethanoic acid is a weak acid. When dissolved in water, it breaks into ethonate and H positive ions. And if you have 1000 molecules of ethanoic acid, only 3 will deassociate like this. Characteristic properties of acids. All acids turn blue litmus red. It's a characteristic property. Acid react with metal to give a salt and hydrogen gas. The metal should be more reactive than hydrogen, or should be above in reactivity series than hydrogen. I can name copper. For example, copper is less reactive than hydrogen. It will not react with any dilute acid. I can give you one example. For example, I can take HCl aqueous reacting with magnesium metal, giving you magnesium chloride. It's a soluble salt plus hydrogen gas. So it's a typical reaction. You can put any metal in place of magnesium. But always remember, copper is less reactive than hydrogen, so it will not react with any dilute acid. Acid react with metal oxide to give you salt and water. Metal oxides are bases, and I can give you one example. For example, sulfuric acid react with copper oxide to give you copper sulfate and water. Property number 4, acid react with alkalis to give you salt and water. Alkalis, as you already know, are soluble bases. You can add any metal oxide, soluble metal oxide in water, and you get a solution of alkali. I can again give you an example. For example, if you take sulfuric acid and react it with potassium hydroxide, it give you potassium sulfate, a soluble salt, plus water. And you have to balance it. You have to write 2 over here and 2 over here. Acid react with all carbonates to give you salt, water and carbon dioxide. It's a characteristic reaction, very important. I can take the example of HCl reacting with sodium carbonate. Carbonates are weak bases to give you salt, water and carbon dioxide. You have to balance it to write 2 over here and 2 over here. Now bases. Bases include metal oxides, metal hydroxides, all alkalis. Alkalis are soluble bases, and bases are strong and weak as well. So strong bases, if you want to name some strong bases, they are sodium hydroxide, potassium hydroxide, magnesium hydroxide. For weak bases, I give you an example of ammonia. Now, if you look at strong alkalis completely deassociate in water. They give you OH negative ion. And you can look at the example I've given over here. Sodium hydroxide aqueous, when sodium hydroxide dissolves in water, it gives you Na positive and OH negative ions. So releasing OH negative ion is a characteristic property of alkalis, and strong alkalis deassociate completely. And ammonia is a weak alkali. If you dissolve in water, it gives you NH4 positive ion and OH negative ion. And ammonia is a weak alkali because it deassociates partially in water. Characteristic properties of bases. Alkalis are bases, so I begin with alkalis. Alkalis turn red litmus blue, and if you react a base with acid, it gives you salt and water. We have already discussed. So in part A, I have written acid plus metal oxides give you salt and water. I can give you an example. Acid like HCl react with metal oxide like magnesium oxide to give you magnesium chloride. It's a soluble salt and water, and you have to balance it. Acid react with alkalis to give you salt and water. Like I can take the example of nitric acid reacting with alkali like sodium hydroxide to give you salt, and of course it's a soluble salt. And water. Bases react with ammonium salt to give you salt, water and ammonia gas. I can take one example of a base like calcium hydroxide aqueous, give you with one ammonium salt, like react with ammonium salt like ammonium chloride to give you calcium chloride salt plus water plus ammonia gas. This ammonia gas can be identified using a moist litmus paper. Ammonia is an alkaline gas. It will turn a red litmus blue. All alkalis contain OH negative ions when dissolved in water. Higher the concentration of OH negative ions, the higher the pH. pH scale, you need to know pH scale. The pH of a solution is a measurement of the concentration of hydrogen ions, and you can say H positive aqueous ions. There is a mathematics involved over here which you will study in A level, but in O level you just have to show some understanding that pH scale is a scale from 0 to 14 on the basis of which we decide whether the solution is acidic, basic or neutral. Like I've written, acidic solution has pH less than 7, alkaline solution has pH greater than 7, and neutral solution has pH equals to 7. So 0 to 7 is acidic, 7 to 14 is basic, and 7 is neutral. So if a value is less than 7, it will be acidic. If the pH value is greater than 7, it will be basic. We have a pH meter, which is a very accurate device to measure the value of pH of any solution. Indicators help you to decide whether the solution is acidic or alkaline. The first indicator is litmus. We have already studied litmus turn acid. Litmus become red in acidic solution and become blue in alkaline solution. Phenolphthalein become colorless in acidic solution, become pink in alkaline solution. Methyl orange become red in acidic solution and turn yellow in alkaline solution. Another important indicator is universal indicator. It's a mixture of dyes which give you a wide range of colors. The chart is given to you. Like in this chart, you can decide the pH of the solution more accurately. Neutralization. Neutralization is a reaction of base with acid that gives salt and water. You have to learn this ionic equation for any acid reacting with alkali to give you water.